Alright, in this unit we're going to explore the topic of counting. Now you may think counting isn't something that's easy to do, but actually there are many problems that are quite complex in which we need some techniques to actually count the possible outcomes. So that's what we're going to start here. So to start off, I want to take a simple example and then see if I can outline a key principle that really is at the heart of all counting problems that we're going to look at, and that's the multiplication principle. So our first example says that Josh rolls a die, then flips a coin. Draw a tree diagram to represent the situation, and then answer the question, how many possible outcomes are there? Okay, so our tree diagram will probably start like this. Let's just pretend that Josh is rolling the die. So when I make my tree diagrams, what I like to do is I start with like just kind of like the starting node. Okay, and it begins like that. So Josh rolls a die. Well, how many outcomes are there when he rolls a die? And we're assuming this is a fair six-sided die. So we know those outcomes. There's the possibility of getting a 1, a 2, a 3, a 4, a 5, or a 6. Alright, so that's just, rolling the die. 6 outcomes. But of course, that's not the end of his experiment here, right? He's rolling a die and then he's flipping a coin. So to extend this tree diagram, what we have to consider is that after he rolls the 1, he'll then flip a coin and he could get a head or a tail. So after he rolls the 1, he could get a head or a tail on the coin. If he were to roll a 2, he could also then flip the coin and get a head or a tail. And so I think you can understand that this is what his tree diagram, or was what the tree diagram will look like. Okay, so that's flipping the coin. And so that tree diagram really has every single possible outcome in this little experiment, right? If you roll a die and then flip a coin, one of these things is going to happen. Either you're going to get, and so if you just sort of follow the path, that will represent an outcome. So like, for instance, he could roll a 2 and then get a tail. So that would be that path. He could, roll a 4 and then get a head. Right, there's that path. So how many paths are there? Well, we just have to count the last branches, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes. Now I do this tree diagram to begin with because while it's nice, it's a visual way to represent the number of outcomes in this situation, it's kind of not practical, right? I mean, if I just extended this problem to be a little more complicated, then a tree diagram really wouldn't be that practical. So what we want to do is kind of look at the underlying reason why the answer is 12 outcomes, and hopefully it's not too difficult to see. I mean, if you look at your tree diagram, you've got 2 branches, right? Two of these yellow branches coming off of each of the 6 red ones. Right? So this 12 is no accident that it's a 12. It's really equal to 6 times 2. Where my 6 is number of ways to roll a die. And my 2 is the number of ways to flip a coin. So when I say ways, obviously what I mean are outcomes. So the number of ways to roll a die and then flip a coin, in the future if you come across this problem, you'll just say, well, there's 6 ways to roll a die, six outcomes when you roll a die, and 2 when you flip a coin. So the number of ways to do that is 6 times 2, which is 12. And this illustrates the most important counting principle that, again, like I said, is at the heart of all the counting problems we'll be doing later on, and that is the multiplication principle. So the multiplication principle formally says that if one procedure can be done m ways and another independent procedure can be done n ways, then the total number of ways to do both together is, I'm going to make this a little smaller to put in the last result, m times n. So there it is, the multiplication principle, very, very important, and I'll be referring to it later on as we do more of these problems.